example 2 is radioactive decay, and it's talking about half-life. Do you remember half-life? Half-life is ln2 over k. All right, so k, then we can figure out what k is because we're given half-life. K is ln2 over half-life. Now, this is something you got to memorize, guys, this ln2 over it. It's not that much because it goes both ways. Half-life is ln2 over k, and k is ln2 over half-life. So we have k. So k for this example would be ln2 over 5750. So if we're talking about our equation, we have A equals, the initial amount is 60 grams, and then we have E to the K. Now, it's decay, so we have to put the negative in here. Don't forget that. This is K times T, which is 3,000. So you should get 41.792 grams. So just remember decay so that the constant is negative, okay? So that was example 2. Let's move on. Example 3 is just wanting you to solve the differential equation with this initial value. So we see we have multiplication, so we can split it up. 1 over y squared dy equals 4x cubed dx. Take the integral of both of those. And the antiderivative of 1 over y is, it's 1 over y squared, is negative 1 over y. And the integral of 4x cubed is x to the 4th plus c. Remember, we just put the plus c on this side. Now, do not fix it. Don't do the 1 over yet because you're going to mess up the c. So keep it as negative 1 over y, and you get negative 1 over negative 1/2, which is 2, right? So 2 equals 1 plus c, so c is 1. And the point was 1 negative 1/2. I suggest you always write out the point even when they do it like this so you don't mess up the x and y. So now substitute, here was what you had. Negative 1 over y is equals x to the 4th plus 1. I should have written plus 1 right there. So plus 1. And now y is negative 1 over x to the 4th plus 1. So that's how you do number 3. Let's move on to number 4. It's a little more complicated. Diff EQ gives you initial value. There's no y, so you would just separate your variables as dy and then x sine squared x dx and take the integrals of both sides. And this one is just going to be y, right? This one you're going to have to use u substitution, so it was pretty easy. You see this x. If we let u equal x squared, then du is 2x dx, so dx is du over 2x. So we end up with a half outside, and then sine u, because the x's will disappear. And so the antiderivative of sine u is negative cosine u, so we have negative 1/2 cosine, put the x squared back in, and you get negative 1/2 cosine x squared plus c. Now let's substitute an initial point. The initial point is 0, negative 1. So negative 1 is negative 1/2. The cosine of 0 is 1, so it stays negative 1/2 plus c. So add a half to both sides, and you get c is 1/2. C is negative 1/2. So your equation is y equals negative 1/2 cosine of x squared minus 1/2. And let's do number 5. All right, this is a good one. It's the second derivative, and it wants you to find the solution. Now, when they give you one of these, okay, just use antiderivatives. Go backwards. So if the second derivative is this, what's the first derivative? So just differentiate. I wouldn't separate your variables or anything. I would just take the antiderivative and put plus c, because they give you an initial condition. So the antiderivative, if you take the antiderivative of x squared y dx squared, you get y prime. Or you could write it as dy dx equals x squared plus x plus c. And they say at x equals 0, y prime is negative 1. So putting 0 in, you would get c is negative 1. So dy dx is equal to x squared plus x minus 1. Okay, or y prime if you want to go that way. And then you want to get to y. Okay, so the solution of a differential equation is a y equals. So you were at a y prime. So y is the antiderivative of this. So that would be x cubed over 3 plus x squared over 2 minus x plus c. And then they tell us at 0, y is 3. So 3 is equal to c, because these would all be 0. So there's your final answer, 1/3 x cubed plus 1/2 x squared minus x plus 3. I'll stop it and do the last two in the next video.